Well, this is one of those projects that was given to me by my brother. He had it sitting in his closet so long he couldn't remember what was wrong with it. So he said, "Here, take it if you want it. It's yours." So I did. I took it home and I started playing around with it, figuring out everything that was wrong with it. And we're going to take a look at it now and see how I fixed everything and returned it to its former glory, just like it was when it left the store in 1978 or 79. I've actually got another Yamaha that I bought about this time frame. It's a lower model than this one is. It had some issues, and back then it was a switch that was bad. I couldn't buy the switch and I didn't know how to fix it, so it's been sitting as well. But this one is pretty well like it was when he was using it. He just put it in the closet and you can't remember what was wrong with it, and I know why he put it in the closet, and we're going to see that here in just a little bit. As you see here, you have to take the fasteners off from the bottom, and there are 5 of them, and I've already loosened them up. Then once you get these out, you want to flip the unit over topside. You don't want to slide it out while it's upside down. You can do some more damage if you're not careful. If you're watching closely, you can already see that some of the repairs have already been made on this unit. We're going to look at these in detail in just a few seconds. Number 1 on my list of things to do, yeah, there should be some lights on the front. The 2 little gauges should be lighted, and also the dial indicator should be lighted. In this case, the incandescent bulbs that came from the factory had long since burned out, and I went ahead and decided, okay, well, let's modernize. I'll put in LEDs. Well, back in the late 70s, of course, red LEDs were pretty common, but blue LEDs and even later on white LEDs were still in the design lab, and they didn't become commercially available until the 90s. Even then, they probably would have been extremely expensive until we got well into the 2000s. Near as I could tell, looking for the power source for these little incandescent bulbs, they appeared to be about 21 volts AC. Of course, I needed much lower voltage than that, and DC voltage to power my little LEDs. We're going to get a little more intimately acquainted with this integrated circuit later on in the video, but since I had to research this circuit anyway, I went back and found out where the power was for this circuit. Turns out it's about 13 volts. Knowing that, I just traced out the hot and the ground, and those 2 wires were adjacent, and then soldered 2 more wires directly to these 2 surface mounted jumpers on the board. This gave me the power for my 4 LEDs. Okay, now that I got my power, now it's time to calculate some dropping resistors and figure out how to solder all this up. The little black boots formerly housed the incandescent bulbs. I kept them around to help mount the LEDs in the holes where the bulbs used to be. The LEDs I used here came from DigiKey. They're 5mm in diameter. They work great for this application. The only thing with DigiKey, of course, is you got to pay a shipping charge of around $7 to get about anything, so definitely wouldn't want to just buy just LEDs. You probably need to buy a few other things. You probably can pick these up, of course, off of eBay or Amazon. Well, now on to the dial indicator, and yeah, this one's a little bit more of a challenge than the other one was. I had to drill 2 small holes in the plastic housing. The original wires came out the top, and that was not an option with the LED. Also, the bottom and the top of the LED had to be flattened, so you only got 5mm instead of the flange sticking out that gave you another 2. The next step, of course, is to route both the wires and the dropping resistor in such a manner that the whole assembly can move back and forward on its track without binding. And here's what that looks like. I'm pretty happy with the result. Actually, the camera makes it seem brighter than it actually is. It's a lot more subdued than this, but it's perfect where you can read it across the room and see how your closeness of your tuning is and see what the actual dial is reading. Now it's time to move on to the next problem this old receiver has. I'm sure we've all heard it. You go to try to adjust the volume, and all of a sudden it gets real quiet, or it grossly drops in volume, and then all of a sudden you get an extremely loud volume as you turn it, and then it gets quiet again, or you get a pop or you get a crack in the sound. Most annoying, and I'm pretty sure that's why this old receiver got put in the closet. Not too surprisingly, the problem is usually right here, or more specifically, it's right here. If you've watched any more of my videos, you know my one-stop fix for all the electronic issues usually involves the solution in a can, in this case WD-40. And I recommend this type that has a flexible metal hose coming out of it. It definitely works to address some places where it's hard to get the spray into and you want to easily target the spray. As another side note, pretty much all the WD-40 spray cans are the same as far as the top of the can. You can actually pop off the top of this spray arrangement and then put it on a can that just has the conventional paint spraying top. It'll pop right on there and work just fine, so you only get to buy this expensive hose arrangement just once. Now the actual problem is over the years these old potentiometers develop a non-conductive coating on the surface of the potentiometer, and that effectively isolates the wiper from the adjustment surface. Using the WD-40 effectively dissolves and removes that oxidation layer and lets the potentiometer go back to its regular function. Almost always you're going to have to take the potentiometer out of the receiver to spray it with WD-40, and as you can see here, the knobs are reasonably tight, but they slide off. There's no sit screws in this old Yamaha, and you've got a single nut that's 9/16 or 5/8 in there to remove, and then you can slide the potentiometer out from the back. There is no need to desolder the unit to treat it, and we're going to take a look at that here shortly. Please note that little white line that runs from the bottom left to the top right that runs directly in behind this potentiometer. This is going to be very important, and I'll get into the cautions in relation to this a little later on in the video. This particular old potentiometer is of a similar design and similar era to the one that we're talking about here. This one that I've got here is two potentiometers on a same shaft. The one we'll be working with on the unit is multiple potentiometers on two concentric shafts. To treat the specific condition that we're talking about here, you need to spray WD-40 into these two slots that I'm showing here. These are the actual contact surfaces where the wiper makes, and these are the oxidation surfaces we're trying to treat. If you don't want to be trying to control the amount of spray that goes in there, here's another option. I bought these 6 cc or 6 milliliter syringes off of eBay, and you can fill these full of WD-40 by squirting the WD-40 in a small bottle and drawing it in the syringe. This keeps the minimum as far as the overspray going into potentiometer and keeps you from wasting too much WD-40. Okay, let's discuss some chemical alternatives to WD-40. Some people swear by WD-40, some people swear at WD-40. There are those that believe WD-40 should never be used around electronics. I've always had real good luck with WD-40, and in this case I definitely think you need a little bit of lubrication with it because you're dealing with a surface that has a wiping contact. I like the WD-40 bottle because it has a flexible metal straw that allows you to bend in different directions, and of course it makes it easier to get in tight spaces. This is the product here that I've got pictured that most electronic technicians that service audio video equipment swear by. It is kind of expensive. It's 4 times the cost of regular WD-40. And it does have lubricating properties, as you can clearly see on the can. I've never used it, never had a can of it, but there are quite a few folks out there that swear this is the best stuff you can possibly use for this application. Any good contact cleaner would probably clean the non-conductive residue off your contact surfaces here, and there are quite a few manufacturers out there that sell that. But again, if you want probably the best for the application we're looking at, yeah, I'd say deoxide is probably better than WD-40. Okay, so you know you're on an FM stereo station and you've got a good solid signal coming in, but the FM stereo light on the receiver is not lit. Well, that usually means you may be receiving a stereo signal, but you're not decoding it in the receiver, so you're getting nothing but mono. Okay, before I start playing with electronics, let's look at some basics. Remember this photo? Make sure your mode switch is in stereo, and make sure your FM muting is on. If the FM muting is off, you're getting nothing but a mono signal. Okay, the next step is to go ahead and put the switches in the correct position, pull the cover off the unit, obviously turn the power off, and then unplug the unit. Now what you're going to do now is basically go in there and check the switches and make sure you've got virtually no resistance across the switch. You need to check both the switches in this case. If the switches check out, then now we've got to take a look at some electronic issues. Again, with the unit powered off and unplugged, you want to go underneath and look for the stereo decoder chip. In my case, it's an LA3350 from Sanyo. I found some links and a discussion on this chip on the internet, and I'll put those links in the description. But basically what happens here is over the years the voltage controlled oscillator has drifted off a little bit, and it's a variable resistor fixed capacitor setting to get the oscillator in the correct frequency. Before proceeding any further, get your phone, your camera out, and take a picture of where these potentiometers are actually set. You may want to mark it on the board so you can make sure you get them back exactly where they were before you made any adjustments. It's probably a good idea to go ahead and give these a quick shot of WD-40 on the wiper surface and go ahead and wiggle them just a little bit, making sure you put them back exactly where they were. There's going to be one coming off pin number 8 and one coming off pin number 16. Pin number 8 is the one you don't want to touch. Pin number 16 is the one that has voltage controlled oscillator. It's going to have a variable resistor somewhere between 2 and 5K. There may be a series resistor in there before the variable resistor, but there would also be a parallel capacitor in this circuit. This particular variable resistor sets the frequency that the decoder chip needs to be able to decode the incoming stereo signal that's being sent by the radio station. Now with the cover off, you're going to want to have the unit turned on, and you're going to want to make sure that you don't touch anything inside the unit except with a plastic screwdriver that we're going to use to adjust this potentiometer. I had to adjust mine about a quarter turn clockwise top, and then you'll reach a setting if you keep turning where the stereo light will go back off after you turn it on. You want to be right in the middle between the turn on and turn off settings, and again mine in this case was clockwise top. Now if you've done this correctly, you'll be rewarded with an FM stereo light, and now you're receiving a stereo signal and you're decoding it and you're getting stereo through both speakers. Okay, for the next portion of the video, pray to whatever deities you hold dear that you don't have to do this. It is intensely frustrating, intensely time consuming, and if you're a type of person that doesn't have a lot of patience or you lose your temper, you definitely don't want to do this. I actually had to do this twice. Once when I took the potentiometer out and knocked the line loose and had to put it back, and the second time when the actual line broke and I had to rethread a new one. So I got a little experience in putting this thing back together, but it's extremely intense concentration type work, and it will require some very, very choice words by the time that you're through, because it's going to require at least an hour to an hour and a half to do it each time. If you have to do this, you probably want to have a second person on standby to hold the line and to help you tie the knots. Trust me, it will make the job go a whole lot quicker. The line both starts and stops at the actual wheel that actually moves the variable capacitor. The line that's attached to the spring winds clockwise. The line that's fixed winds counterclockwise. Remember this shot? Here's where I screwed up the first time. When I took the potentiometer out, I didn't have the ability to take the line off. And when I did, I knocked the line loose from the upper pulley. Then I had to go back in and restring the whole thing. Here's where it pays to have two people. The best way to get the line off and to make sure that you don't have to go through what I went through is to loosen up the set screws on the back of the tuning knob and slide this shaft off, holding this shaft while you take the potentiometer out. Again, it's best to have two people for this. After you get done, all you got to do is just slide the shaft back on over top of it and you should be intact. But you want to make sure that when you take it off of there, you're holding everything tight so nothing comes unraveled. Now here's something you don't want to do. The little shaft on the main wheel that activates a variable capacitor will slide out. It'll come right out. On the end of that shaft is a small gear and some limits that are on there to make sure that you can't adjust it too far. If you slide it out, that old gear is going to drop off, and it is extremely difficult to get that gear back on and back into registration. Whatever you do, don't pull the wheel off. That'll take it out of the shaft here for this variable capacitor. Note that there will always be 3 lines on the top of this adjustment wheel. Whenever you adjust it, you're always going to see 3 on top. Now for the correct line path, it comes off the adjustment wheel, in this case being tied to the fixed point, goes through the lower pulley, then it wraps around the adjustment knob that actually allows you to tune stations, then it goes out, back across the potentiometer, which is where I got in trouble, and then there's an upper pulley, and then it comes back on the top side to catch the indicator, and then it goes back through the pulley you see on the top left there, and then back underneath the wheel where it ties off to the spring connection. Here are a couple videos of how it looks when it's working correctly. In this case, when the capacitor is all the way open, that's 108. When the capacitor is fully closed, that's 88. Note that, as I said before, there are always going to be 3 lines on the top of the wheel. Make sure you've got 3 or you don't have enough adjustment room to go full scale. Now let's talk about replacing this line if yours is broken or rotted away or not there. What you probably want to go with is 6-pound test monofilament fishing line. I found anything bigger than that, the lines tend to wrap up over top of themselves on the adjustment knob, and the whole thing jams. To run the line, you tie off at the fixed point, go around the wheel 3 times, coming off at the top, then you go down underneath the pulley right there by the adjustment knob, wrap around the adjustment knob for the channel changing 3 times, then out around the far pulley, back across where the dial indicator is, then across the pulley that's on the far left, and then after that it comes back underneath and ties off to the spring. You'll want to leave an extra 1 foot to 18 inches on whatever that length turns out to be to easily tie your knots. I posted a link in the description on how to tie a clinch knot. That probably is the best way to do this. An extra added tip on this one would be to follow the clinch knot, but you don't pull the knot tight in that initial loop where it went through what would be the hook, or in our case the spring. You slide a 1/4 inch diameter Phillips head screwdriver through there after you've marked the line at the exact spot where you want the knot to be. Then you can use the free line to pull the line and adjust where the knot will actually be located. Once you get the correct location that you've indicated by your marking, you just take out the screwdriver and pull the knot tight. If you wind up having to make an adjustment, which you probably will, to adjust for tension, you want to do that at the adjustment knob where you've got those lines wrapped around the adjustment knob multiple times. I start out with 3 wraps around the adjustment knob, and then if you have to add more wraps around it, everything should still work okay, and you're only adding about 3/8 of an inch every time you wrap it around there. As far as how tight the line should be, here's what that looks like, and yes, it's about guitar string tight. When you're running the new line, keep in mind that your capacitive wheel should have 3 lines lapped around it. Then of course it comes out and goes down, comes back on the top, and then when it goes underneath the wheel to tie off to the spring, you've only got 1/4 of the way around the wheel to tie off. This will allow you to get some spring tension on the line. And again, it does pay to have 2 people when you do this, one to hold the line and one to be tying the knots. The dial indicator should be at 88 when you do this. The capacitor will be fully closed and you should already have 3 wraps around the wheel. The very final thing to do is to get the dial indicator set correctly. You slide it into place, run the line under the 2 tabs that you should have already bent out slightly, then gently close the tabs on the line, making sure you don't cut the line, or of course you'll have to do the whole thing all over again. Now I would demonstrate, but of course if I put on a radio station and the music comes on, that's copyrighted material and YouTube immediately demonetizes the video on that basis. So unfortunately I can't give a demo here for you. Well, thanks for watching. Hope you found this both interesting and useful. If you find one of these at a garage sale, scoop it up. They're excellent receivers. They've got really good sound. If yours is home, sit in the closet, dig it out, make these few minor repairs, and it'll be perfect for wherever else you want to put it on stereo sound too. If you found this useful, please definitely consider giving me a like, and please do check back often, because I've got a whole lot more little tinkering I'm going to do. Got a little something coming up on mosquitoes I think you're going to want to see. So, until our paths cross again, take care. Catch you on the next video.